In this video, we're going to look at the log mean temperature difference for heat exchangers. First, we're going to start with parallel flow heat exchangers. This is a case in which both gases or both liquids are flowing in the same direction. It'd be like a case such as this. And suppose we have these temperatures, the hot gas or liquids coming at 150 degrees and exiting at 100 degrees. And the cold liquid or gas is coming in at 50 and exiting at 80. So first, let's calculate the difference of these left temperatures and always take the highest minus the lowest. So we'll focus on the left temperatures here and take the highest minus the lowest. We'll call this delta T1 is 150 minus 50, which is 100 degrees. Then go to the right side, the right end, and take the difference here. Once again, always take the highest value minus the lowest, gives us delta T2, which is 100 minus 80, which is 20. Now let's calculate the log mean temperature difference for these. So we're going to use the log mean temperature difference equation. This is delta T2 minus delta T1 divided by the log of delta T2 divided by delta T1. Now notice this is the natural log, ln. So let's take a look at the case that we have here. We have the delta T2 was 20. Delta T1 was 100. Like this. And if you put this into your calculator, you're going to have negative 50 divided by the log of 1 over 5. And that's going to give us 49.7 degrees F, like this. What if we had labeled the left side delta T2 instead of delta T1, and then the right side delta T1 instead of delta T2? Would that make a difference? In other words, if we had called delta T2 150 minus 50 equals 100, delta T1 100 minus 80 is equal to 20. Let's do that log mean temperature difference calculation. And so again, with the switching the delta T2 and delta T1, let's put that into this equation here. And put that in your calculator. And guess what? You get the same thing, 49.7 degrees. So whether you call the left end delta T1 or delta T2, you still get the same answer. Of course, the reason is because of this up here. If you take a look at what we have up here, remember the log can be broken up like this. And then notice if you were to factor out a negative and switch these and then distribute that negative in the numerator, you would get delta T1, delta T2, log delta T1, log delta T2, like that. And then, of course, you could write this as log delta T2 over delta T1. So as long as whatever is here is in the numerator down here, whatever is here is in the denominator, you'll get the same answer. So it doesn't matter whether you call left end delta T1 or delta T2. Finally, let's take a look at the counterflow heat exchanger. That's a heat exchanger which the gases or liquids flow in opposite directions. Let's look at the same scenario we had a minute ago, where the hot gas is coming in at 150 and exiting at 100, and the cold gas or liquid is coming at 50 and exiting at 80. Once again, notice they're flowing in opposite directions. And just like before, let's call the left side delta T1 and take the difference here, always the higher temperature minus the lower. Difference between 150, excuse me, difference between 150 is 50. Do the on the right-hand side. Difference between 150 and 80 is 70. Now let's calculate the log mean temperature difference for these. Let's calculate the log mean temperature difference for our counterflow case. And we said delta T2 was 70. Delta T1 was 50. Log of 70. Log of 50 gives us, when you put this in your calculator, 59.44 degrees. So the counterflow heat exchanger gives us a higher log mean temperature difference. So the log mean temperature difference is better, higher for the counterflow case. So it shows that the counterflow is much more efficient. In any case, there you have it for the log mean temperature difference calculations.